So hello everyone and welcome back to the channel. This will be the first video for Java and this is week 1. तो इस वीडियो में मोस्टली कुछ है नहीं, मतलब वीक 1 में ऐसा कुछ है नहीं जिसका मेरे को कोडिंग करके दिखाना पड़े. सो आई विल जस्ट कवर फ्रॉम द नोट्स. बाकी जहाँ पे आई एक्चुअली नीड टू कोड आई विल शो इट, है ना, कोडिंग कर. फर्स्ट वीक इज जस्ट एन इंट्रोडक्शन टू जावा, नॉट रियली इंट्रोडक्शन बट रियली एन इंट्रोडक्शन टू ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग एंड एब्स्ट्रैक्शन एवरीथिंग. सो वीक में ज़्यादा कुछ है नहीं, बस जीए है, जीआरपी है भी नहीं. ओके, सो लेट्स स्टार्ट. ओके, तो फर्स्ट कॉन्सेप्ट आता है वीक 1 में, प्रोग्रामिंग कॉन्सेप्ट. प्रोग्रामिंग लैंग्वेज. व्हाट इज अ प्रोग्रामिंग लैंग्वेज? ओके, तो सबसे पहली बात, प्रोग्रामिंग लैंग्वेज क्या है? प्रोग्रामिंग लैंग्वेजेस आर यूज्ड टू कन्वे कंप्यूटेशनल आइडियाज टू अ मशीन दैट कैन एग्जीक्यूट देम. सिंपल भाषा में बोला तो प्रोग्रामिंग लैंग्वेज ऐसा एक लैंग्वेज है जिससे हमें क्या करना है. जैसे 2+3 अगर हमें करना है तो हम बस 2+3 को ऐसे किस तरीके से बताएं कि मशीन समझ जाए. लाइक हाउ डू वी express 2+3 in machine language so that the machine can understand and execute it. Okay, that is programming language in the shortest way possible. Okay, so machine language is the only programming language that machine can understand directly. Okay, so basically machine language is the only language that machine can understand. Obviously machine cannot understand 2+3. It has to be binary coded. Okay, a computer can only understand zeros and ones, nothing else. So what is a machine language? Machine language instructions are binary coded and low level machine instructions. Machine language instructions are binary coded and low-level machine instruction may transfer the contents of one memory location to a CPU register or add numbers into registers. Okay, what registers? Registers are like temporary variables. Okay, it is the CPU's own temporary variables and it uses them to store intermediate results, intermediate values. Okay, registers. Data retrieval and data writing on a register is really fast because it is the integral part of the CPU itself. Okay. So what does a machine language instructions do? Okay, so they are binary coded first of all, and low level machine instruction. So these are the examples of what low level machine instructions may do. Okay, so it may transfer the contents of one register to another. For example, if I want to copy something, that is just basically meaning I am transferring one. Okay, let's say in Python we do a is equal to 10 and b is equal to a. So you're just copying the contents of a into b. So if a is my register and b is my second register, then b is getting copied result from a. Okay, so a is being copied into b. That is a type of copy procedure for registers. Or it can add two values like 2+3 and then store it in another register like a is equal to 10, b is equal to 3, c is equal to a plus b, so 13. Okay, like that. So there are some examples of what low level machine instructions can do. Or yeah, this is just example, you can read that. Okay, now then why do we need high level programming language? Okay, so we can obviously do, for 2 it will be 0 0 1 0 and 3 it will be 0 0 1 1. Okay, so like that we can obviously binary code it, but obviously when we are developing a really big software or we have a ton of instructions, then we cannot binary code everything. So to make it easy for the programmers to write programs, we needed high level language which will translate English language or any English language to machine language. Okay, so we can just write 2+3 and the language like Python, it will translate that into machine language while running. It will convert that into machine language before running. Okay, so we do not have to binary code it itself. The language takes care of that itself. Okay, so high level programming languages were developed to enable programmers to write programs faster than low level machine language. A programming language is intended for mathematical computation, allows programmers to express numerical equations directly. Okay, simple. basically meaning we can write in our native language, and the language will take care of the binary coding in the backend. That's all. Okay, now the conversion from high level language to machine language. So there are two mechanisms, or mm, two ways which we can through which we translate this. Okay, first is compiler and second is interpreter. Compiler, what is compiler? This is used by most languages like Java. Mostly old languages use this. Okay, you can like sort of think of it like this way. Okay, uh, Java, C++, all are compiled languages. Okay? Wherever you have to compile it first before running, there is basically compiler. Okay, that's in the name itself. Okay, so a compiler translates the entire program into machine language in single go. Okay, so let's say I have a Java program uh, which will initiate two variables first, and copy that variable into and store the results in a third variable, and then print the variable along with print a line that says the sum is. Okay, so this whole 4 5 lines, it is one Java program. So Java, since it is a compiled language, it will translate this entire 4 5 lines into machine language in one go. Okay, so that's why it is faster than interpreter, but it also requires more memory because it is doing a lot more work in a single go, and that's why it also generates intermediate code. Okay, so see, that's the simple what is compiler. Okay, compiler translates the entire program into machine language in a single run, faster than an interpreter because it takes the entire program during translation, generates intermediate code. Okay, so it requires more memory. Simple. Interpreter is just the opposite. Like Python is an interpreted language. Okay, so since Python is an interpreted language, it takes the lines one by one. Okay, so as like it runs line by line. Okay, so if I have the same program in Python, then it will first run the first line, second, then third, like translate the first line, then second line, then third line. It will go line by line. Okay, so it translates the machine language, translate the high level into machine language line by line and not at once. It is obviously slower because it is taking one line at a time. Okay, and it never generates intermediate code, so it requires less memory. Okay, simple. That's all about interpreter. Okay, interpreter translates the entire program into machine language line by line. Slower than compiler, obviously. Never generates intermediate code. Okay, that is the basic difference between compiler and interpreter. That's all you need to know, honestly. Then there comes the topic of programming styles. Okay, there are mainly two ways of programming styles. Programming style is in which way we are telling the computer, like uh, what is the logic behind what logic are we telling to the computer. There are two main ways we tell the computer. First is we tell the computer how to achieve the result. Okay, like we define steps that how this first, do this first, do this, then do this, and then you will arrive at the result. So this is imperative programming. Okay, we focus on how the result is achieved, and then there is another way in which you tell the computer what result to achieve. Okay, like at the end I tell it just that I want the sum, I want 5. Okay, uh, or I want the subtraction of this. Now how the subtraction is carried out is really left up to the computer. So on the second way, which is declarative programming, we tell the computer what result to achieve, and the how part is left to the computer itself. Okay, so let's go one by one. Okay, so first is imperative programming. In imperative programming, we tells the computer exactly how to do something, like first do this, then this, then this, keep, and then this, and keep doing until you arrive here. Okay, this is imperative programming. You clearly define instructions line by line. Okay. In imperative style, we tell exactly how we want to achieve the result. Okay, and this style obviously uses intermediate variables. Okay, best is recursion. Okay, best example is a recursion example. This is the first week, so most examples will be from Python point of view, at least the basic examples. So def factorial f is equal to 1, n is equal to n minus 1, f is equal to f minus, so return f. Okay, so whenever we are calling this, okay, there will be a set of intermediate results. Okay, and we will see only the final results. Let's say 3 factorial of 3. So we will see only the result for 3, but it will also generate the result for 2, 1. Okay, 2 and 1. Okay. So that's why this is imperative side of programming. Okay, where we tell the computer what how to do, exactly how to do, and it requires intermediate variables. Okay. Then comes declarative programming. Okay. In declarative programming, we tell what to do. Okay, and how to do is obviously left to the computer itself. Okay, tell the computer what would we like to do and leave the part of how to do it to the computer. Okay, in declarative style we say what results we want to get or what exactly we want to do. Okay, we tell the computer, okay, this is what I want to do, or this is the result I want to do. Kind of like talking to ChatGPT. Okay, you tell it what you want to do, or you tell it what result you want to achieve, and then it tells you how to achieve that. Okay, so that is a crude type of example for declarative. Okay, this style does not use any intermediate variables. So see, most of you get confused of like here we are returning it, but here we are returning directly. Okay, so this is directly. Okay, so it is not actually storing this. Okay, it will also generate for 2 and 1, but it will not store them anywhere. It will just give the result here. Okay, see the return. Okay, you will just get from the return values. Okay, so it is returning a variable, so that's why it is called an intermediate variable. Okay, here we are not returning any intermediate variable. Okay, so there is no point or anything from for storage. Okay, and obviously this will require a little more storage, although negligible, but this will use a little more storage because it will have intermediate variables. Okay, so those are the two main types. Wow, I am literally adding variables. This is stupid. Okay, next thing is the role of types. Okay, so the role of types, data types, from the name itself we can see that data types. Okay, so every variable has a specified data type. Okay, now assigning data types has two ways, like in Python, which we in Python we just write a is equal to 10 and it will automatically take it as integer data type. Okay, that is called dynamic typing, dynamic allocation, or dynamic typing, anything you want to call. Not dynamic allocation, sorry, dynamic typing. Dynamic allocation is a thing. Sorry. Dynamic typing. Okay. So in Python, like a is equal to 10, b is equal to a string named my hello. Okay. So Python will automatically assign an integer data type to a and a string data type to b. This is called dynamic typing, where we do not have to explicitly mention the data type. Okay. On the other hand, there is static typing like Java or C. Okay. In those we have to explicitly mention, like in Java we say int x, okay, or float y. So we can only store integer values in x and only store decimal values in y. Okay, or we say string z. Okay, so z will only store string and not integer or float. So before actually assigning the values to a variable, we have to explicitly define what the data type of that variable is. That is known as static typing. Okay, so that's all that there is in the role of types. Okay, you can read this. Okay, I have shared these notes in like week 1 to week 4 notes are shared in drive folder. I will add the link in the description. You can read this, but this is just simple. That's all there is. Okay, then comes memory management. Okay, obviously whenever we call a function, okay, a specific block of memory is given to it for it to complete its execution. Okay, uh, well, let me take a sip of my coffee. Sidebar conversation, but a frappe is the best thing you can get. Obviously, if it is from a good enough cafe, but a frappe is the best thing, especially dark chocolate frappe. I love that shit. Okay. Anyways, let's get back to it. So memory management. Whenever a function is invoked for execution, function needs memory for local variables. Obviously, we saw intermediate variables. Okay, but there will also be local variables which we define, like a is equal to 10, b is equal to hello. So it obviously needs memory to store them. Okay, these local variables are used to store intermediate results. Okay, so yeah, local variables can be used to store anything. Okay, not only temporary results, we can also use them to store constant values. We can use them to uh, store values which we will need further down the road. Okay, so yeah, so whenever a function is executed, it obviously needs memory for a lot of different things, not just variables. It obviously needs memory for its own running also. So what is an activation record now? A lot of people I saw were confused in actually activation record. Okay, if you don't if you can't understand what an activation record fully is, you don't have to pass the or to do the questions well enough. You just need to remember two things, which I will tell you in the later part, and just little below. Okay, but what is an activation record? Activation record is a block of memory associated with the invocation of a function. Okay, so whenever a function gets invoked, it needs a memory. Okay, so we can't just allocate all the memory. Okay, so the block of memory that gets uh, like say our memory has a to z. Okay, like a to b is one part of a memory, b to c is another part, let's say that. Okay, so whenever a function is called, let's say I gave it b to d. Okay, b from b till d is a memory, part of memory or block of memory that gets allocated to it. Okay, so that b to d is an activation record. Okay, that's all. You can think of it like that and it will be easy for you. Okay, so that block of memory that gets associated is an activation record for that function. Okay, so obviously whenever like there is not a single, there won't be any one function that is being called. Okay, so whenever a function called, there are a lot more things already going on. Okay, so that's why memory management is usually done in a stack. Okay, for Java mostly. uh, so you have learned PDSA, or even if you haven't, I'll just tell you what a stack is. So stack is like that, last and first out. Okay, so you keep adding things at the bottom. Okay, if you say this is my stack, if you say this is my stack, if there is a coin at the bottom, okay, we keep adding from here. Okay, so I added a coin, another on top, on top, on top, on top. Okay, so that is and whenever I'm taking it out, I won't take it out from here obviously. Okay, I'll take it out from here. Okay, so that is last one first out. And if you are wondering, the opposite is queue. Okay, in a queue, obviously you must have seen queues everywhere. Okay, so this is a queue. First person comes here, then second person comes here, then third person comes here, then fourth person comes here, and it keeps going with. Okay, so and whenever we are taking it out, obviously the first one person will go out first. Okay, so queue is first and first out, and stack is last and first out. Okay, so so this is a stack. So whenever a function is called, it just keeps getting added into the stack. Okay, and whichever function is done, it will get popped out. Okay, so obviously this function will get done first, so then it will be popped out. Okay, that's how memory is managed. Okay, so see, the same thing is done here. Activation record is a block of memory associated with an invocation of function. Invocation just means calling. Okay, nothing else. An activation record is pushed into the stack when a function is called and is popped out when the control returns the caller function. Okay, basically when the function is done, and instead of this, you can just think that whenever the function is done executing, it will just get popped out. That's all. Okay, so this is a activation record. Okay, so first thing is activation record has three main things. Okay, they have written two, but three main things. Okay, first is the storage. Okay, second is the control link, and third is the return value link. Okay, these three are the main things. Okay, identifying a full activation record, or these fill in the blanks will depend on these things. Okay, so I'll get the main thing out first. Okay, so control link is storage for parent function call. Okay, also known as previous activation record. Okay, so whenever you see storage, okay, the execution is bottom to top in this one. Okay, in the GA or PA, I don't remember which one, the execution is top to down. Okay, so remember that, don't get confused. Okay, just see whichever is the highest. Okay, so if the like 3 2 1, obviously, so then the execution will go like this. Okay, so this is a full one stack. Okay, this is the stack for function call 3. Okay, uh, then this is the function call. Okay, for the next one. Okay, it is a recursion function, obviously the factorial, this one. Okay, so it is a recursion call. Okay, so main thing is the storage of, let's say this one. Okay, let's say 2. Okay, so focus on this 2. Okay, so the storage for this, sorry, the control link for this one will be joined to the storage of parent. Okay, storage link of parent. Okay, this is the line. Okay, storage for parent. Okay, simple. And then the return value of that function will be associated with the function call of parent. Okay, so whenever the parent calls the child function, then the return value of the child will be associated with that function call. Okay, so this is return value link. Okay, cool. So this is how you do it. Control link is for storage for parent function call. Return value link, previous function call. Okay, then let me show you what it does. Okay, so whenever we call this, okay, factorial of 3, it will call factorial of 2, factorial of 2 will call factorial of 1, and then at last this will get returned. Okay, so the control link of 1 will be associated with storage. So as soon as what returns, return 1. Okay, so 1 returns here. Okay, so 1 is stored here. No, sorry. Okay, so I'll just remove this because I do not like to clutter my notes. Okay, so the control link are obviously associated with the storage of the factorial 2, and the return value link is associated with the function call. So if there are more, like let's say 4, then 4 3 2 1, and it will be just like that. One's control link will be associated with 2's storage, and one's return value link will be associated with the function call of factorial of 1, like this. Okay, that's how you do it. That's all you need to remember. Okay, these 2 lines are the main things you will have to remember. Okay, that which the storage will be associated with. Okay, that's all. Whenever factorial 3 is called one activation record in the stack memory, every activation record has a memory for local variables, control link, and return value link. Control link points to the previous activation record. Return value link takes ways to store the result. Okay, so return value link, obviously return value link is associated with the function call, so obviously that will store the result. Okay. That's all there was. Okay. Then there comes heap memory. Okay, heap memory is used for dynamic memory allocation. Okay, so stack is defined. Okay, or let's say a list is defined. Okay, we define a list that we will have 5 elements, 6 elements, but let's say we do not know how many elements there will be. Okay, so at that moment comes heap memory, which is a dynamic memory allocation. Okay, where is heap memory used? Like a linked list. Okay, a linked list, nodes can get added here. No, sorry. Okay, if it's a doubly linked list, then nodes can get added here or here, and it will just keep increasing. Okay, will just keep increasing, and we can also delete this. Okay, so this will be like this then. Okay, so the size of the memory, size of the list keeps increasing or decreasing, so that's why we need dynamic memory allocation here, so that we can keep the memory free. Okay, or we can keep the memory well organized as or we can keep allocating memory as the list is growing or shrinking based on what the list is doing, obviously. So, and the second important thing about heap memory is that Java does not clear it automatically. Like whenever a function is called whenever a function is done executing, if it is a stack memory, then it will just get popped out by itself. But in heap memory, it is not like that. If the work is done, then Java virtual machine uses a garbage collection mechanism to clear the dynamic memory or clear the heap memory. Okay, so you can read this. Okay, that's the just what I told in English. Well, so yeah, we go through this. Now there comes a really important part: abstraction and modularity. Okay. So abstraction and modularity. First is stepwise refinement. There is not much here. It is just telling how to break a function into smaller and smaller subtasks. Like obviously, if you have a big goal or a big software which you want to build, you cannot think of the big picture always. You have to break it down into smaller components which you then solve. Okay. Like if I have to print 1,000 prime numbers, then I just cannot think of the goal all the time. Yeah, I have to break it down. So first I need a list to store 1,000 numbers. Okay. Then how to insert a number into the list, like what condition should it fulfill to get added into the list. Okay, so we keep breaking it down into smaller and smaller tasks, and then we write the code or instructions for those specific tasks, and then this whole set of instructions at once becomes a full code to achieve printing the first 1,000 primes. Okay, so that's all it is written here. You can just go through this once. And data refinement. Okay, data refinement is another important thing. It is a basic thing to keep in mind while the system design keeps evolving. Sorry. So while the system designs keep evolving, the changes data structures might be needed to change. Okay. So let's say we have a create account, we have a deposit, withdraw, print statement. Okay. So while print statement, let's say a print statement just for basic purpose, it just prints the last 5 transactions. Okay. And we have a list for that. But now we might not want a list. Okay, we also want a transaction record, like full record, including who it was sent to, on which date, everything. Okay, and not just a transaction amount. Okay, so now we need a table. Okay, so like this type, the data type keep changing. Okay, this is a basic example of a print statement. Obviously it will be a little different in programming, but this was just a basic example. Okay, so this is how it works. Okay, so yeah, just read that once. This is the same thing. Okay, then I will explain the important concepts in depth. Don't worry. There is not much questions come. This is just for your own understanding. Okay. Okay, modular software development. Okay, so modular software development is the same thing which I told, like in data breaking down. Okay, so this thing for this refinement. Okay, stepwise refinement. Obviously, you break it down into smaller and smaller steps. Okay. Then we write the code for each step. This is just what modular programming means. Okay. So let's go into modular software development. Modular software development is like divide and conquer. Okay. It is important to divide large and complex programs into smaller and manageable parts called functions or procedures. Okay. Obviously, we can't just keep thinking of the big picture, like we didn't think we just keep the goal in mind, and then we keep breaking it down to smaller, and the code of instruction, the piece of instruction that fulfill a specified task, that is encapsulated into a function or a procedure. Okay, and these functions or procedures can be solved independently. We use refinement to divide the program into functions or procedures, and each of these functions generate a specific solution. Okay, these solutions generated by those functions are combined to provide the overall solution. Okay, so each function or a procedure generates a specific part of the solution, and these all these solutions, when combined at once, then they give the ultimate solution, okay, for the goal. Then comes prototyping. Prototyping is a development method, invokes implementing smaller parts of a program in a simple way to understand the design will really work. Okay, so prototyping is developing a crude version of a program first. Okay, we break it down, then we break it down in the simplest forms. Okay, then we build the program, then we test the program. If the program works well, then we keep, this is called a prototype, like the crude basic design, and then we add complexity to it. Okay, we added a little more complexity, then we tested it again. This is the second prototype. Then we added a little more complexity. This is a prototype 3. So we keep prototyping like this till we achieve the ultimate goal, which is desired by us. Okay, so that's what prototyping is. Simple. We keep we make a crude design, we implement it, test it. If working, we add more things to it, again test it, keep developing it till we achieve the end result. Okay, then there are two important concepts in modular programming development: interface and specification. Interface is a description of the parts of a component that are visible to other program components. Okay, we'll see example later on. Okay, so let's say I have a stack. And it has a list, okay, which will take the values, okay, in which the values will be stored, which will be pushed into the stack, and then I have to push and pop. Okay, so what I will, but the stack also has different things like indexing. Okay, for example, indexing, okay, or accessing. Okay, let's say these also are parts of stack, but if I am letting anyone use the stack, then what I will tell them, you can just see the list. Okay, you can just use push and pop too. You do not I will not let them mess with the indexing or accessing. Okay, I will just let them see push and pop are the methods that are allowed, and L is the state, okay, or the data. Okay, sorry. Okay, so interface is a description of the parts of component that are visible to other program components. So the description of the parts, like L is what? L is a list. Push and pop are what? Push and pop are methods. Okay, so this description is called the interface, while specification is description of the behavior of a component as observable through its interface. Okay, so the behavior of this, what does push do? Push adds an element to the stack. What does pop do? Pop eliminates or pops out an element from the stack. So this thing, this description is called the specification. Okay, so simple. We'll see more in-depth examples as we go on. Don't worry. This is just a basic example. Okay. If you don't understand, just go through it once more. Okay. Then there comes another important abstraction. Okay. Abstraction is it is an important principle in object-oriented programming that separates the implementation of a program from its interface. Okay, so how a program is implemented, it should not depend or should not interfere with the interface itself. Okay, let's go in more depth. Okay, so first is control. There are 3 types of abstraction: control abstraction, data abstraction, abstract data types. Okay, control abstraction are, sorry, there are 2 types: control abstraction, data abstraction. Abstract data types are different thing. Okay, control abstraction is the abstraction I implement using a procedure or function. Okay, so control abstraction is implemented using procedures or function. What are they used for? They are used to encapsulate a block of code. Obviously, when you are writing a function, let's say a fact. Okay, these 3 lines. Okay, these three 4 lines are encapsulated by this function, this procedure. Okay, so they are used to encapsulate the block of code, and the implementation of a function is a function body. So implementation is this, okay, which consider the instruction that will be executed when the function is being invoked, obviously. So these 3-4 lines is the implementation, okay. So these lines will be executed when the function is ran, okay. So we encapsulated this, okay. Now if user is calling the fact, okay, factorial of 3, he isn't concerned with what the lines of code are, what the implementation is. He is just concerned with the interface, okay. That is the factorial name of the function and how it is being called, okay, the calling. He is not concerned with how the how it is being executed, how are we arriving at the result, okay. So he is just concerned with the result, okay. So that's what it means for control abstraction, that he is not concerned, or we are not showing how it is being used, how it is being implemented. We are just allowing him to use it. The English is really bad in these notes, and I have OCD with English, so sorry for that. Second is data abstraction. Data abstraction refers to hiding information about the way data is represented. Okay, simple again. We will see an example of data abstraction later, but let's say whenever factorial is called, he is calling with 2.00. Okay, but in so this is a float. Okay, this is obviously a float. Okay, but inside, when we are taking fact n, we are converting n to int of n of will, है ना? So even if it is float or it is integer, it will work. Okay, n is equal to Python example. Okay, don't go into Java. N is equal to int n. Okay, so we have inside the function, we are representing it as int always. Okay, so n is always an int inside, but the user does not know that, and he doesn't need to know that. Okay, we just tell him to pass an integer or float. Okay, and even if he calls fact 2, it will work. Even if he calls fact 2.0, it will work. Okay, 2.00, it will work. Okay, so the user is not concerned with how the data is represented inside the variable. Okay, he is just concerned with the usage. Okay, so data abstraction refers to hiding information about the way data is represented. We are not telling him that we are storing it as an integer or a float. Okay, then comes abstract data type. Okay, abstract data type exposes what the operations that are performed in data structure and what are the values permitted to store in data structure rather than how it is implemented. Okay, so what did it mean? Okay, so abstract data type, first thing, it just tells the user what the data is stored. No, sorry, what are the values permitted? Okay, let's say we have a structure called stack. Okay, we have a stack, and let's say I tell him that only you can only store numbers like 2, 4, no float, no string. You can just store integers. Okay, so this is one paradigm of abstract data type. We tell the user what are the values permitted. So here the values permitted are integer. Okay, and then there is another push and pop. He can only do these things. Okay, but cannot mess or access these. Okay, or not access, he cannot mess with these functions. Okay, he can only push or pop into the stack. Okay, so this is another paradigm that the operation that are performed. Okay, he is not concerned with the implementation or what all implementations are. The only implementation he is concerned about are those which we allow. Okay, समझ आया? मतलब basically he is not concerned, उसको नहीं पता कि इंडेक्स कैसे हो रहा है ना, और एक्सेसिंग कैसे हो रहा है, he doesn't know. What he knows, he can just push pop, मतलब वो just डाल सकता है and निकाल सकता है from a stack. Okay, कोई कवर नहीं करेगा. So he can just push or pop. Okay, So push or pop, and after that, what are the values permitted? Okay, so we tell him कि only integers values can be stored. Okay, कि सिर्फ integer values ही store कर सकते हैं हम. So the user is concerned with these three things only: methods that are allowed to him and values that are to be permitted to be stored. Okay, क्या स्टोर कर सकता है एंड क्या कर सकता है उसके साथ, बस ये दोनों यूजर को पता है. और कैसे हो रहा है, क्या हो रहा है, ये सब हमें पता है, प्रोग्रामर को पता है, उस यूजर को ना ही पता है और ना ही उसको पता होना चाहिए. दैट इज द मेन idea behind abstraction, and abstract data types are just those data types that allow this. That's all. Okay, so hence operations and values permitted on the procedure are visible to other parts of program using a public interface. Obviously, so ये जो भी हमने देखा, we store this in a public interface. Okay, and public interface में जो चीजें हैं, only those operations and values are visible to other users or other program parts, and private वाले are not visible. That's all. Three main goals क्या है abstraction के: identify the interface of the data structure, है ना, इंफॉर्मेशन हाइडिंग को सप्लीमेंट करना, है ना, डेटा स्ट्रक्चर यूज मेनी डिफरेंट वेज, है ना, पढ़ लेना, सिंपल सी चीज़ें हैं, मेन गोल्स. ये एग्जांपल वही है जो मैंने बताया, पढ़ लेना एक बार, है ना. देन कम्स रियली इम्पोर्टेंट, जावा पूरा बेस्ड ही ऊप्स पे है ना, ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग. सो ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग में first main चीज है object. So what are objects? Objects are abstract data types. First thing, objects are abstract data types. Every object has its own data, also called state, and operations, also called methods and messages. Obviously, है ना. तो हर ऑब्जेक्ट के पास अपना खुद का डेटा होता है जिसको हम स्टेट बोलते हैं, और उससे खुद के ऑपरेशंस या मेथड्स होते हैं. ऑपरेशंस होते हैं जिसको हम मेथड्स या मैसेजेस कहते हैं, है ना. एंड जब भी हम एक पूरा प्रोग्राम लिखते हैं, ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग को ध्यान रख के पूरा प्रोग्राम लिखते हैं, तो उस प्रोग्राम में क्या होता है, उसमें बेसिकली देयर आर लॉट ऑफ ऑब्जेक्ट्स. ओके, एंड दोज ऑब्जेक्ट्स इंटरेक्ट विद ईच अदर टू गिव द फाइनल program its shape or give the final result. Okay, then the second thing comes inheritance. Inheritance is you inherit your wealth from your dad. Okay, whatever your dad had, a home, okay. Second comes inheritance. So inheritance is like you are inheriting from your dad, even your dad inherited from your grandfather, like that. Here, objects can also inherit the procedures or function or the implementation of its parent. Okay. So the definition of inheritance is when an object reuses the implementation of another object. Parent-child relation. Okay. The society will get me killed one day. Inheritance is the process by which one object reuses the implementation of another object. Okay. For example, if you consider an organization that has two types of employee, named employee and manager. Okay, so if we have two types of employees in a company, let's say employees and managers, normal employees and managers. So every manager is also an employee. Okay, so let's say employee has two basic details like date of joining and name. Okay, name and date of joining. So manager will also have those values. Okay, or those details, but it can also have extra details like when the day he became manager, the day he got promoted, or maybe he gets a bonus. So that will also be another detail that will be added to manager. But manager can inherit these two values from employee. Okay, like the date of joining and his name. Like these two details can be inherited, but it can also add its own variables or procedures to the mix. Okay, that's what inheritance means. Okay, inheritance means you inherit some properties from a parent, but it don't necessarily need to be stuck to those properties only. You can also add your own properties or procedures. Okay, then there comes the subtyping. Okay, so subtyping is like if A is a subtype of B, then wherever A can be used, B can be used instead. Okay, yeah, whenever an object of type B is used, A can be used. Okay? So it is a type of specialization. Okay. The main important thing for us being a subtype is every, like, it should be a all to all relationship. Okay, like employee and manager. If manager needs to be a subtype of employee, then every employee needs to be a manager. Okay, so if employee wants to be a subtype of manager, then yeah, so right. I'm saying that if employee wants to be a subtype of manager, then every employee should be a manager. Okay, this is the main important thing. It should be all to all relationship. Okay, but since this is not the case, so employee is not a subtype of manager, but manager can be a subtype of employee. Why? Because every manager is an employee instead. Employee also. Okay, so this is a all to all relationship. Okay, em- every employee is not a manager. Okay, but every manager is an employee. Okay, so then employee, sorry, manager is subtype of employee. Okay, simple. Okay, it will take a while to get used to. Even I get confused. Okay, so this is what subtype means. Okay, and obviously whenever there is a subtyping, so whichever the subtype is, it can use all the functionalities or procedures of the parent, uh, and also all the data variables, obviously. So if manager is a manager is a subtype of employee, then it can use name, whichever the employee has, salary, bonus. If needed, it can define its own bonus. Okay, or own variables. But let's say we have these two from parent, and I add one more, that date of promotion. Okay, date of promotion, for example. So it can add its own variables, own data, and it can inherit the rest from the parent, or whichever ऑब्जेक्ट इट इज अ सब टाइप ऑफ. तो सब टाइपिंग क्या होता है, मतलब उसका एक चाइल्ड, ओके, पेरेंट चाइल्ड, यहाँ पे पेरेंट चाइल्ड रिलेशनशिप समझ सकते हो. तो बेसिकली क्या होता है, तुम अपने पेरेंट का सब टाइप हो, है ना. जो भी तुम्हें पेरेंट के पास है वो तुम्हारे पास भी है, बट तुम्हारे पास खुद की अपनी चीजें भी हैं. सो दैट इज सब टाइपिंग. ओके, सिमिलरली इन एम्प्लॉय मैनेजर केस जो यहाँ पे एग्जांपल दिया है, एंड सब टाइप होने के लिए ऑल टू ऑल रिलेशनशिप होना जरूरी है. एवरी एम्प्लॉय इज नॉट अ मैनेजर. ओके, सो एम्प्लॉय इज नॉट अ सब टाइप ऑफ मैनेजर. ओके, मैनेजर इज अ सब टाइप ऑफ एम्प्लॉय. क्यों? क्योंकि हर मैनेजर एम्प्लॉय भी है इंस्टेड. ओके, सो इसलिए मैनेजर सब टाइप ऑफ एम्प्लॉय का. अब मैनेजर क्योंकि सब टाइप है एम्प्लॉय का, तो ये एम्प्लॉय ऑब्जेक्ट की सारे प्रोसीजर्स एंड डेटा वैल्यूज को एक्सेस कर सकता है, जैसे नेम हो गया, सैलरी हो गया, एंड बोनस जो फंक्शन हो गया. बट इट कैन ऑल्सो चेंज द फंक्शन फॉर इट्स ओन सेल्फ. लाइक मैनेजर को ऑब्वियसली बोनस ज्यादा मिलेगा, सो हम उसको 0.2 से मल्टीप्लाई कर रहे हैं. सो इट कैन रीडिफाइन देम ऑल्सो, एंड इट कैन ऑल्सो एड मोर वेरिएबल्स जो उसके खुद के हैं. जैसे मान लो मैनेजर में एक और वेरिएबल है डेट ऑफ प्रमोशन, जिस दिन मैनेजर बना. सो दैट्स व्हाट सबटाइपिंग इज. ओके, सो जहाँ पे भी मैनेजर की जरूरत है वहाँ पे एम्प्लॉय यूज कर सकते हैं. जरूरी नहीं कि वो सही इम्प्लीमेंटेशन होगा. लाइक ऑब्वियसली बोनस वहाँ पे गलत देगा, 0.2 इंटू होगा, बट अगर हम सेम इम्प्लीमेंटेशन रखें तो हम उसको यूज कर सकते हैं, है ना. दैट्स व्हाट इट मीन्स. ओके, so what is the main difference between inheritance and subtyping? Subtyping refers to compatibility of interface. Okay, मतलब जहाँ भी ऑब्जेक्ट ए जरूरत है, ऑब्जेक्ट बी की जरूरत है, वहाँ पे ऑब्जेक्ट ए यूज कर सकते हैं. इफ इट इज अ सब टाइप, ऑब्वियसली इफ ए इज अ सब टाइप ऑफ बी, तो जहाँ पे बी की जरूरत है वहाँ पे ए यूज कर सकते हैं. इनहेरिटेंस रिफर्स टू रीयूज ऑफ इम्प्लीमेंटेशन. ओके, इनहेरिटेंस का मतलब क्या होता है, इम्प्लीमेंटेशन रीयूज करना. If A inherits from another type B, then A can reuse the functionality of B without redefining it एक सेकंड में वो एक चीज कंफर्म कर लेंगे. हाँ ठीक. So inheritance refers to reuse of implementation. If type A inherits from another type B, then A can reuse the functionality of B without redefining it. Okay. Also, it can add more features obviously if it is required. Okay. Here's an example. So let's say there is a data structure called DQ. Okay. This is a data structure that is a double-ended queue. Okay. So queue में basically हम क्या करते हैं, इधर से निकालते हैं, इधर से डालते हैं, कोई कमेंट नहीं करेगा, है ना. बट अगर इफ इट्स डबल एंडेड देन हम यहाँ से डिलीट कर सकते हैं, यहाँ से भी डिलीट कर सकते हैं, यहाँ से भी इंसर्ट कर सकते हैं, यहाँ पे इंसर्ट कर सकते हैं. दैट इज द बेसिक DQ data structure. DQ supports insertion and deletion at both sides. Okay. तो 4 फंक्शन है इसके: insert front, delete front, insert rear, delete rear. Okay. Now if we just use insert rear and delete front. Okay. Not this. Insert rear, delete front. Okay. First in, first out. क्या है ये? Q. Okay. है ना. And वहीं on the other hand, if we use insert front, delete front, है ना, ये क्या है? Last in, first out. क्या है ये? Stack. Okay. तो यही बोला है. We get a normal queue. Other hand, if we use insert front and delete front, we get a stack. Okay. In other words, we can implement queues and stacks in terms of DQ. Okay. So obviously, मतलब stack और queue इनहेरिट कर रहे हैं, है ना, क्योंकि ये जो फंक्शंस है ना, जो ये फंक्शंस यूज कर रहे हैं वो डिफाइंड कहाँ पे है? वो डिफाइंड है DQ के अंदर, है ना. जो ये फंक्शन यूज कर रहे हैं वो फंक्शंस डिफाइंड है DQ के अंदर. सो वी नीड टू इनहेरिट देम फर्स्ट टू यूज देम. ओके. In other words, you can implement queues and stacks in terms of DQ. So as data types, stack and queue inherit from DQ. On the other hand, neither stack nor DQ are subtypes of DQ, or queue are subtypes of DQ. Okay. Queue subtype नहीं है, वही all logic वाला. All stacks are not DQ. Okay. And similarly, all queues are not DQs. No, sorry. All DQs are not stack. All DQs are not queues. Okay. है ना. तो DQ is not a subtype of both. Sorry. अरे यार ये बहुत confusing है. Okay. Wait, पढ़ लेते हैं. देखो, stack and queue can use function from DQ, inherit. Okay. They don't support all function from DQ. Okay, not subtype. तो stack and queue subtype नहीं है. क्योंकि all stacks are not DQ. वैसे ही all queues are not DQ, है ना. So they don't support all functions from DQ, not subtype. Okay, simple. Okay, still confusing. Okay, so let's go over it again. Okay, if you just so stack क्या है? 2 फंक्शन यूज कर रहा है, 2 स्पेसिफिक फंक्शन यूज कर रहा है. Queue 2 स्पेसिफिक फंक्शन यूज कर रहा है. So they don't support all the functions of DQ. Okay, so that's why this is not a subtype. Okay, of DQ. क्योंकि stack is using insert front and delete front, but it cannot use insert rear or delete rear. Okay, so it does not support all the functions. Similarly for queue, so ये दोनों subtype तो नहीं है, but ये दोनों inherit कर रहे हैं चीजें. Okay, because they are inheriting their functions from the DQ parent class, so their inheritance holds here, subtype doesn't hold. But वहीं अगर हम देखें DQ के, अगर हम इसको उल्टा देखें तो DQ में जितने भी functions है, अगर हम उल्टा देखें, स्टैक में जितने भी फंक्शन है DQ कैन यूज दैट. क्यू में जितने भी फंक्शंस है DQ कैन यूज दैट. ओके, बिकॉज पेरेंट क्लास है तो ऑब्वियसली उसी से इनहेरिट हुआ है. सो इन दिस केस, इन दिस स्पेसिफिक केस, अगर हम स्टैक में कुछ अलग डाल दें, एक अलग फंक्शन डाल दें खुद से, एक्सेस का मैंने डाल दिया, रैंडम एक्सेस का मतलब बना के डाल दिया मैंने फंक्शन, तो उस केस में फिर DQ भी सब टाइप नहीं होगा, बट इन दिस केस जहाँ स्टैक सिर्फ दो फंक्शन इनहेरिट कर रहा है और कुछ अलग से नहीं डाल रहा, वैसे ही क्यू दो फंक्शन इनहेरिट कर रहा है dq से और कुछ नहीं डाल रहा अपने से, then in that case the dq is a subtype of both stack and queue. dq is a subtype of both stack and queue in this implementation because it is just inheriting those same functions. dq can use both functions of stack and it can use both functions of queue. But if we add more functions to queue which dq doesn't have, then it won't be a subtype. Okay, so in this specific implementation only, dq is a subtype of both stack and queue. होप दिस इज क्लियर. ये लास्ट में जो बोला, गो थ्रू इट वंस मोर, है ना. वीडियो पीछे करके एक और बार पढ़ लो, समझ में आ जाएगा. एक और बार सुन लो, पढ़ो, समझ में आ जाएगा. ओके, देन कम्स डायनामिक लुकअप. डायनामिक लुकअप मीन्स मेथड टू बी इन्वोक्ड एट रन टाइम. ओके, सो डायनामिक लुकअप मीन्स हम जस्ट कॉल करते हैं ना फंक्शन को, लाइक वी जस्ट इम्प्लीमेंट एन ऑब्जेक्ट एंड वी कॉल इट. लाइक फॉर एग्जांपल इफ देयर इज स्क्वायर, like there are four classes, square, circle, and let's say there's two, square and circle, and both have a draw function. Okay, which will draw the specific shape. Okay, like let's say drawing a circle, drawing a square, these two are the draw functions for the both. So when we implement a new square, let's say shape s1 is equal to new square s1 dot draw, है ना. So name दोनों में same है, the name of the function is same for both, like in class square and class circle the name draw is same, but the implementation is different, and we do not need to worry about that. The language takes care of it. This is the concept of dynamic lookup. When we call s1 dot draw, since s1 is a square, it will call square dot draw and not circle dot draw. Okay, even though the name is same, it won't get confused or won't give errors, because whenever we are calling it, we associate a specific class to it, so that class's implementation only is called. That is dynamic lookup. So same procedure function name can be used across the classes with different implementations. Okay. Then comes the third most important thing, classes. A class is a template that describes what objects can and cannot do. Okay, an object is an instance of a class. Okay, so what does class define? Class defines what an object can or cannot do. This is an object. Okay, point is an object, and this is defining what it can and cannot do. Okay, so this is, let's say it can have two variables. Okay, this is saying that the point object can have two variables. Okay, let's just think of this only. It can do anything else, like it cannot print them, it cannot add them, it can do nothing except just having two variables. That's all. So this is what class does. Class defines what an object can and cannot do. That's all. Now we can keep adding things to a class, obviously. So and now we are adding a method to it. We are adding two methods to it. Okay, so now in all of this, what it can do, now the class is defining that it can have two variables. This point object can have two variables. It can increase those two variables, increase those two variables by a certain amount, dx. Okay, it can increase those two variables certain amount, and then it can calculate distance. Okay, so this is what the class is defining now. So the class is now updated. It instead of just having two variables, it can now increase those two variables by a specified amount, or it can calculate distance between those two. Okay, similarly, change in internal implementation, like we discussed earlier. Okay, data abstraction. Okay, data abstraction and control abstraction, those things. Okay, while calling this, let's only think of this one. Okay, while calling this, I can just call new p. Forgot the syntax. Objp shape, this one. Yeah, so point p is equal to new point with, let's say, 3, 5. Okay, So now I will just pass this only. Okay, I did not know or do not need to know whether inside it is stored as a or b, x or y, or r or theta. Okay, so now here what they're saying is uh, they are using polar implementation, polar representation. Okay, in polar representation, r and theta are the two variables that are stored. So now instead of just writing 3 and 5, they store it as this one. Like 3 is 25 plus 9 is 35 34. Okay, so 34. Okay, and tan inverse 3 by 5. Okay, 5 by 3, and theta is tan inverse 5 by 3. I forgot the value. Okay, so 5 by 3. Okay, so this is how it is stored inside. But do I need to be concerned about how they are stored? No, I can just call it directly. Okay, I can call another one. Point p1 is equal to new point 2 comma 6. Okay, so now again I do not need to know about how they are being stored internally, or how they are being processed internally. Okay, if I want to if I want the distance, then I can just call p1 dot o distance whatever है ना. Okay, ये पूरा नाम. Okay, I do not need to know how the variables are stored inside. Simple सी बात है ना. So this is the implementation or the abstraction thing we talked about. Okay, so वही चीजें बस बता रखी है. एब्स्ट्रैक्शन पर्पस क्या है, जैसे कि हमने बात किया, हाइड इम्प्लीमेंटेशन डिटेल्स. ओके, क्लास पॉइंट है ना. कंस्ट्रक्टर रिमेन सेम है ना. दोनों में देखो कंस्ट्रक्टर सेम है. a is equal to 0, b is equal to 0. डिफॉल्ट कंस्ट्रक्टर सेम है, बट द इम्प्लीमेंटेशन इज डिफरेंट इन बोथ. सेल्फ डॉट एक्स यहाँ पे कर रहे हैं, मतलब बेसिकली डायरेक्ट हम स्टोर कर रहे हैं एक्स वाई कोऑर्डिनेट्स में, और यहाँ पे हम आर थीटा मतलब पोलर कोऑर्डिनेट्स में से स्टोर कर रहे हैं. बट ऐसा कोई मतलब नहीं है, उसका हमें कोई मतलब नहीं है, ना ही यूजर को मतलब है. कंस्ट्रक्टर सेम है, द इंटरनल रिप्रेजेंटेशन डज नॉट मैटर, एंड द यूजर इज नॉट कंसर्न विद दैट. इट इज ऑल्सो हिडन फ्रॉम हिम, सो इट डजंट रियली मैटर हाउ वी आर स्टोरिंग दैट. सो दैट्स द पॉइंट ऑफ एब्स्ट्रैक्शन. बट पाइथन में क्या दिक्कत है, पाइथन डज नॉट अलाउ एब्स्ट्रैक्शन. मतलब अलाउ तो करता है, बट इट इज अप टू द प्रोग्रामर. ओके, इट इज नॉट डायरेक्टली इन्फोर्स्ड बाय द लैंग्वेज इटसेल्फ. लेट्स से मैंने 0.57 किया एंड p डॉट x करके मैं चेंज कर सकता हूँ, विच शुड नॉट बी पॉसिबल, है ना. मान लो p डॉट x करके मैंने चेंज तो कर दिया, बट इफ इंटरनल इम्प्लीमेंटेशन इज डिफरेंट, है ना. अगर इंटरनल इम्प्लीमेंटेशन डिफरेंट है, जैसे मैंने अगर इंटरनली मैंने पोलर कोऑर्डिनेट्स में डिफर कर रखा है, तो उसको समझ नहीं आएगा कि x क्या है, क्योंकि x है ही नहीं यहाँ पे, है ना. तो यहाँ पे वो एरर थ्रो कर देगा, है ना. तो एब्स्ट्रैक्शन इज नॉट इन्फोर्स्ड बाय द लैंग्वेज इटसेल्फ इन पाइथन. इट इज अप टू द सोल डिस्क्रिप्शन ऑफ द सोल डिसिप्लिन ऑफ द प्रोग्रामर इटसेल्फ, है ना. हाईली डिपेंडेंट ऑन द डिसिप्लिन ऑफ द प्रोग्रामर. Then comes subtyping and inheritance through an example. Okay. Let's say class rectangle. Okay, ये Python कोड है ना, ध्यान रखना है Python कोड है, जावा अभी तक नहीं आया. तो क्लास रेक्टेंगल हमने डिफाइन किया, है ना. तो अब एक रेक्टेंगल ऑब्जेक्ट में क्या क्या है, दो वेरिएबल्स हैं, एरिया का प्रोसीजर है, पेरीमीटर का प्रोसीजर है ना. नाउ स्क्वायर इज अ सब टाइप ऑफ रेक्टेंगल, वी आर डिफाइनिंग इट एज सब टाइप ऑफ रेक्टेंगल. ओके, सब टाइप है तो फर्स्ट इनहेरिट तो करेगा ही, है ना. तो इनहेरिट इसने किया, बट स्क्वायर में क्या है, सिर्फ एक साइड है ना. मतलब विड्थ इज इक्वल टू ब्रेड्थ होता है ना. सॉरी, क्या होता है, सारे साइड इक्वल होते हैं बेसिकली. नो माइंड. लेंथ इज इक्वल टू विड्थ इज इक्वल टू लेंथ इज इक्वल टू विड्थ स्क्वायर डॉट 2d, सॉरी, है ना. तो सिर्फ एक ही इनपुट चाहिए हमें, तो हमने यहाँ पे कंस्ट्रक्टर चेंज कर दिया, है ना, क्योंकि ये सब टाइप है, हमने कंस्ट्रक्टर चेंज कर दिया, है ना. सेल्फ डॉट विड्थ इज इक्वल टू एस सेल्फ डॉट हाइट, हमने वेरिएबल सेम रखे, है ना. क्योंकि हमने वेरिएबल सेम रखे हैं अभी भी, ऑल्दो हमने कंस्ट्रक्टर बदला है, बट हमने वेरिएबल सेम रखे हैं, तो इट कैन स्टिल एक्सेस दीज टू, है ना. क्योंकि सेल्फ डॉट विड्थ अभी भी इसके पास अवेलेबल है, और हाइट भी इसके पास अवेलेबल है. तो इवन दो वी आर नॉट डिफाइनिंग एरिया एंड पेरीमीटर exclusively in square, it can still give me area and perimeter, because the parent from which it is inheriting, or which the class which is it is a subtype of, has those definitions, there has those function definitions. Okay, तो वही लिखा हुआ है, since we have implemented width and height like for rectangle, we don't need to change area and perimeter. Okay, तो ये वाला इसलिए काम करेगा, पढ़ लेना ये सेम ही है जो मैंने ऊपर समझाया, बस इंग्लिश में लिखा हुआ है. हाँ, अब यहाँ पे देखो उसी का उल्टा अगर हम यहाँ पे चेंज कर दें, सेल्फ डॉट साइड इज इक्वल टू एस कर दें, ये सब टाइप है ना, तो एरिया एंड पेरीमीटर अभी भी इसके पास अवेलेबल तो होगा, है ना. अगर हम कॉल करेंगे तो ये नहीं देगा कि नॉट रिकॉग्नाइज्ड, है ना, ये रिकॉग्नाइज तो करेगा बट उसके पास विड्थ नहीं है, हाइट नहीं है ना, तो ये एरर थ्रो करेगा कि विड्थ एंड हाइट नॉट डिफाइंड, ऐसा कुछ एरर दिखाएगा, है ना, नॉट फाउंड, कुछ भी ऐसा कुछ एरर दिखाएगा, हाइट विड्थ एंड हाइट नॉट फाउंड, है ना. तो इस चीज के लिए हमें क्या करना पड़ेगा, हमें यहाँ पे स्पेसिफिकली एरिया का एंड पेरीमीटर का फंक्शन डिफाइन करना पड़ेगा. वी नीड टू स्पेसिफिकली डिफाइन एरिया एंड पेरीमीटर इफ वी आर चेंजिंग द वेरिएबल्स. ओके, तो यहाँ पे साइड इनटू साइड, है ना, और यहाँ पे साइड जो भी है ना, ऐसे करके दोनों को डिफाइन करना पड़ेगा हमें, है ना. तो दिस वाज सब टाइपिंग एंड इनहेरिटेंस, है ना, पढ़ लेना, पूरा लिखा हुआ है यहाँ पे. The subtype can do everything the parent type will do and more, and in particular that means it should have all the instance variables that the parent type would have declared and more, because function would use these instance variables. Okay, वही चीज जो भी function variables हमने define किए हैं parent में, those should be available in the, those same variables should be defined inside the child or the subtype defined like in square, क्योंकि एरिया एंड पेरीमीटर उन्हीं वेरिएबल्स से डिफाइंड है, या फिर हमें नया उसको डिफाइन करना पड़ेगा, है ना. अब एग्जीक्यूट कैसे होता है, हाउ अ जावा प्रोग्राम इज एग्जीक्यूटेड. ओके, सो फर्स्टली वी जस्ट राइट, ओके, हाई लेवल प्रोग्रामिंग लैंग्वेज इंस्ट्रक्शन. लेट्स से दिस इज माय क्लास टेस्ट. ओके, दिस इज माय सैंपल जावा, like this is my sample java. Okay, so first when we run this command javac sample.java, java compiler will come into picture. Okay, so javac means java compiler. So the first step is the compiler will compile the whole sample.java and check for any syntactical errors or anything. Okay, and if all is correct, if everything is fine, then it will convert that language into a new file, that is bytecode. So it will convert the whole language, a whole set of instructions into bytecode. Okay, so then when we run the bytecode java sample, sample is the bytecode name. Okay, so when we run the java sample, the jvm comes into picture, java virtual machine comes into picture, and it runs and it converts the bytecode into machine language level instructions like binary coded, and then it gives the output. Okay, so first thing is you write high level language. Okay, then you call javac, which compiles, okay, into bytecode. Okay, I remember I said compile, not interpret. Okay, so javac is the compile, it will compile it into a bytecode if there are no syntactical errors. Then when we run java, jvm comes into picture and it converts it into machine language and gives output. Okay, so this is the whole workflow of how java program is ran. Okay, so yeah, that was all for week 1. Week 1 doesn't have much. This was all. Go through the notes once, go through this video twice if you need to. 1 hour video it has already been, so yeah, the videos will keep improving. I am recovering from a lot of stuff right now, so the voice and everything might be a little down. Sorry for that. Been through a lot. Okay, won't bore you with the details, but yeah, have fun, all the best.